Welcome back, ladies and gentlemen. In this video, we're briefly looking at the 5 major equations of motion, also known as the Big Five sometimes. You'll hear a word that I'll throw on as well called kinematics. These are the equations of kinematics. Well, kinematics is basically just describing motion. That's all it really is. It's not explaining the motion and trying to figure out, well, why is it happening that way? It's just kind of describing it. And there's a lot of mathematical ways we do that. And so we have these big 5 equations. These are important. You can see the first one, average velocity, is equal to displacement divided by time. You can see acceleration is equal to change in velocity divided by time. You can see that displacement is equal to initial velocity times time plus 1/2 times acceleration times time squared. And you've seen these 3 equations, the first one's here, from previous videos. There's 2 more though, and these 2 come about from a couple interesting ways. Number one, for an object that is accelerating, it could be handy to have an equation for an accelerating object that does not have time in it, no t in the equation. And so we end up with this one. And where this comes from is basically a substitution of 2 different equations, kind of basically allowing us to eliminate time. What we have is final velocity squared is equal to initial velocity squared plus plus 2 times acceleration times displacement. And that'll be a useful equation as well. And notice there's no time in it, so we don't need to know the time if we're going to end up using this one. Finally, well, it's another equation for average velocity. Sorry, I got a little sloppy right here on the word average, AVE. If you think about this, well, an average velocity is it's an average. And how do you find the average of things? You add them up and you divide by how many things you got. So if we take 2 things like an initial and a final velocity, we can add those together, and since there's 2, we divide by 2, same thing as multiplying by 1/2. And that'll give us the average velocity. This is going to be really handy, having 2 equations for the average velocity. You're going to end up using them both from here, here and there, I should say. So these are the big 5 equations of kinematics, or equations of motion. I want to show you something though, and the reason is we're going to have to get into this, and this is a skill you're going to develop, and it really is essential if you're going to go on to study more interesting science topics, more interesting mathematics classes. This is an absolute must. It's not a very hard skill to develop, but it takes practice like anything else, and we're going to build on this. Rearranging an equation. So I'm taking this initial equation, actually it's the first one on our list, right? Average velocity is equal to displacement divided by time. We're going to take this and solve for final velocity. You go, wait a minute, this equation doesn't have final velocity in it. Well, all right, but actually it does, because in this delta symbol, remember, that's changing something. That's going to be final minus initial. So we're going to take our equation and break this up into final position minus initial position. And that's still divided by time. We didn't have to break up this one, and the reason why is, well, we're solving for the final position here. And so we're going to now do some rearranging. And we'll get more into this. I will help you out more with this, but basically what I'm going to do is multiply both sides by time. That brings the delta t over here. There it is. And then I have to add, and so then we're left with this. And then I have to add initial position to both sides to get rid of it on this side. And so I end up with final position equals average velocity times time plus initial position. Just a little intro to rearranging equations, which you will do a lot of. And it gets real easy. You just have to be sort of reasonably alert when you're doing it so you don't make mistakes. One last thing before I wrap this one up. There's a mistake somewhere on this page. Can you find it? Thanks for watching. I'll catch you next time.